water, wind, fire. Technology is changing the way we perceive the natural world. And yet, despite resources such as cutting-edge imaging, artificial intelligence, and mountains of data, researchers still have to be able to make sense of it all. This is one theme of the Water, Wind, Fire Conference, and the theme of today's episode of Coast to Canopy. You can find a video version of this podcast at wfsu.org/ecology blog, or the WFSU Ecology YouTube channel. Today we're talking about the first Floridians Conference, which happens October 3rd and 4th at the Monticello Opera House. The theme this year is Adapting and Overcoming, or Conserving, Water, Wind, and Fire in Florida's Big Bend. And we have several of the presenters representing multiple research disciplines, which I'm excited about. We're going to dig into the ecology, the ancient past, and the climate of our area, and the new technologies that are allowing researchers to more fully explore our natural world. This is Coast to Canopy, an ecology podcast from WFSU Public Media. I'm Rob Diaz de Villegas. So joining me in the studio today, we have Dr. James Dunbar. He's the board chair of the Osceola Research Institute and the former state archaeologist for the state of Florida. Welcome, Jim.
Good to be here.
We have Ryan Truchelet, the co-founder and chief meteorologist of Weather Tiger, a Tallahassee agricultural meteorology expert witness and hurricane forecasting company. Thanks for joining us.
Thanks for having me.
All right, and we also have Jenny Rogers, a remote sensing and geospatial technology analyst with Tall Timbers Research Station in Land Conservancy.
Happy to be here.
All right, great to have you all here. I'm looking forward to this conversation. So let's talk about the conference first. It's primarily an archaeological conference.
Well, no, actually it isn't.
No, okay, yeah.
It's trying to look at it's sort of archaeology, but it's also natural sciences.
Yeah.
And it's trying to look at the Big Bend area and how it developed through time, and just basically looking at the environment, the vegetation, the animals, the people, and how things change through time. But it involves a lot of geology. It involves multispectral imaging. It involves weather forecasting and those type of things. And one of the reasons we decided to go on the theme of water, wind, and fire is the last 3 hurricanes that have hit here. We've had some wildfires, and I thought it would be a good time to address sort of a broad spectrum of different topics that are all related in a way, but they're not related directly to each other.
Well, I find, like, I guess in the discipline of archaeology, I mean, you draw upon all of these different other disciplines too. I mean, it's all very heavily intertwined, right?
Right. It's as much as we can bring to the context of things, the better off we are. And what I mean by that, if you find an archaeological site in the middle of nowhere and you have to draw on, well, what are the diagnostic artifacts? That gives you a sense of time, but also, well, how did these people live? And if you have a place where you can core for pollen and get that kind of information, bare earth LIDAR may give you some kind of information of structures at the time. But we have somebody that's a geologist out of Canada that's going to come and talk, and Brendan Fentry, and his interest is looking for weather conditions in ancient times. And he's found some evidence of hurricane activity in Florida 12,500 years ago or so.
Oh, wow, yeah.
So, we have a variety of speakers, and it should be a very interesting kind of conference. And for archaeology, we'll try to use everybody's everything to try to make sense of what happened in the past.
Right. And before we get into all the different presentations, which are it's a really interesting and diverse lineup, talk about why Monticello is an ideal place for a conference, the first Floridians Conference. Talk about sort of the rich kind of archaeological record around around that area?
Well, we had the first conference, I don't know, 2012. Can't even remember the year, tell you the truth, but we had just come off of doing investigations at the Page-Latson site, ground site in the Osceola River, had immaculate preservation of plant remains, of animal remains, you name it, it had it. And so that first conference sort of looked at Page-Latson, but not only that, all the other early sites in the Americas that we could get our hands on. And from there, it sort of branched out, and we were trying to really not only archaeology, but the earth sciences. That's what the Osceola Research Institute is really trying to promote. And conservation in this area of rare and endangered resources.
Yeah.
Like the American mink. Did you know there were mink in here? Well, yeah, there are down near the coast. They're endangered. Why? Hurricanes. So it all ties together in a funny kind of way.
Right, right. And I just want to follow up on the Page-Latson site for our listeners. I know a lot of people in this area know the Page-Latson site, but for those who don't, and anyone who's listening to this as a podcast around the country, talk about the significance of the Page-Latson site.
Well, at the time, it was I was working with a fellow, David Webb, who was a paleontologist, and myself, and some archaeologist, and Lee Newsom, who's a paleobotanist, and things like that. And we really pieced together it's not an occupation site. It's more like a human activity area that took place in the Osceola River when the water tables were lower. We think they butchered a mammoth. We have cut marks on a tusk and some other things. And it was 14,500 years old, which caused all kinds of consternation in the community of archaeology because everybody knew and nothing could be older than 13,000 years. And here we're at 14,500. Since that time, there have been other discoveries. White Sands National Park is the famous one that dates from, I think, 24 to 23,000 or 22,000 years old. Human footprints followed in the tracks of like giant sloths. They were hunting the animals. And it's fully carbon datable because there are seeds that were in the sediment and that kind of thing. And there's been two major studies done now that say that's a real archaeological site. So getting into my end of things, why is that important? Because they were saying that people couldn't have been here longer than 13,000 years ago because the Cordilleran and Laurentine ice sheet closed off and there was no path to come into the Americas. Well, if people were here in the late glacial maximum, they were already here. And I think we're going to find human occupation sites or activity sites somewhere in the Americas that are dating to the 30,000 range.
Wow.
I think that's a high possibility now because at the late glacial maximum, maybe people weren't coming in because the Cordilleran and the Laurentine ice sheets blocked off everything, but they were already here is the point. So anyway, it makes it interesting.
So let's go around the table. Let's talk about you guys' presentations. Ryan, let's talk about our Florida climate. So what's your presentation about?
So I'm going to be looking at both the climate of North Florida and potentially how it is changing with an eye towards climate extremes, impactful weather. You know, in the last 2 years here in Tallahassee, we've had the warmest month in Tallahassee history, August 2023, that ended with the first major hurricane landfall ever in Appalachia Bay, Adelia. We then followed that up with the most impactful tornado outbreak in Tallahassee history in May of 2024. We followed that up with the first Category 4 hurricane landfall ever in Appalachia Bay in Helene. And we wrapped it all up with probably the most impactful winter and ice storm that we've ever had in January of 2025. So no rest for the weary as a forecaster and as a meteorologist. But I want to put those kind of extreme events into a historical context. Because, you know, we have a long historical record that we can look at here in North Florida. We've got good temperature records going back to the late 19th century. We've got records of snowfall. We've got records of hurricane landfalls that go back 175 years in a very rigorous way, and we've got hundreds of years more data, kind of in piecemeal from writings and paleotempestology, which is digging up sediments and looking for layers indicative of historical landfalls. So I'm going to be looking at what we can expect from the climate of North Florida. What is it? What are the influences that shape our weather? It's a fascinating place meteorologically because Tallahassee is right on the cusp between, on one hand, to the north you have a continental climate. Continental climates tend to be hot in the summer, cold in the winter. Cold air is generated from basically air over land masses for long periods of time. So you can have extended periods of time when there's not a marine influence on the weather here in North Florida. On the other hand, we're 20 miles from the Gulf, and the Gulf has warmed with time. We're much warmer now than we were 30 or 40 years ago, and that is a subtropical and even a tropical influence on our weather. So I'm going to be going back and looking at all those forms of impactful weather like extreme heat, extreme cold, snow, ice, hurricanes, tornadoes, droughts, and looking at all the influences on that from the perspective of both diagnosing it, how does El Nino, how does La Nina come into play and modulate those risks, and how are those risks changing with time?
Right, and so we've had more extreme events, but in general, Florida, where we are right now, North Florida, has always been kind of a unique area as far as the influences. And we were talking before about we typically would have had more 100-degree days than any other place in Florida, and more freezing days than any other place in Florida. So we're already in sort of, even before you factor in whatever climate change, we were already in kind of a unique area, right?
Right, absolutely. North Florida is the hottest part of Florida in the summer, both in terms of average daytime high temperatures, but also in terms of potential extremes. So the hottest temperatures ever in the state of Florida, as well as the coldest temperatures ever in the state of Florida, have happened in the central and eastern panhandle. The hottest day ever in Tallahassee was, I believe, in 2010, and it hit 105 degrees. If you go back and you look at other major cities across Florida, just this summer, Tampa, for the first time ever, recorded a 100-degree day. And I believe the Miami metro area has almost never seen a 100-degree day either.
Yeah.
And that really speaks to the tropical influence on the weather in Central and South Florida being much greater than in North Florida. So, for instance, in Miami, down at around 25 degrees north latitude, you get pretty strong trade winds out of the east blowing east to west. And that's a very typical tropical weather pattern. It's the same weather pattern that you have in Puerto Rico or the Virgin Islands or the Lesser Antilles. You get these, basically trade winds that blow through the summer months. And those trade winds stop the extremes in heat that we can see in North Florida because, the water temperatures historically, in the Bahamas, they're in the mid 80s. So it never can get too high above, that water temperature. Now, the flip side of that is, of course, the temperature can't get too far below what the nearby water temperature is either. So, typical summer day in Miami, historically, high of 90, low of 76. Typical summer day in Tallahassee is much more variable. If the winds are out of the north, and you don't have that Gulf moisture influence, that's how you get those days where the high temperature is 100 degrees or more. Now, obviously that's always been a historical possibility, but we are seeing increased frequency of those temperature extremes, days of 100 or greater, over the last 2 or 3 decades.
And drought too, right? Or is that just my perception where I see I remember just as a gardener, I would look at my plants in the garden and it didn't rain for 6 weeks, like maybe 5 or 6 years ago. And are we experiencing more drought too, and longer and harsher droughts?
We are. And one of the big reasons for that is one of the fingerprints of climate change is an increased prevalence of La Nina versus El Nino events. Now, just to provide some context for listeners here, La Nina and El Nino refers to sea surface temperature anomalies in the equatorial Pacific Ocean, specifically the central equatorial Pacific. We're talking southwest of Hawaii. We're talking the vicinity of the international dateline. So this is far from Florida. And you might be wondering, okay, great. Why am I talking about sea surface temperatures along the international dateline? Well, that's because sea surface temperatures in that area are kind of like a climate pacemaker. They really set the tone for weather patterns worldwide, including in North America. So, historically, models that have tried to project global weather patterns forward with anthropogenic warming influences have really split on, is there going to be more El Nino? Is there going to be more La Nina? This is sensitive stuff. It's a feedback between ocean and atmospheric circulations, and it's tough for models to get that right. Observationally, however, if you go back and you look at the last 40 years, one of the only places on Earth where average sea surface temperatures are not getting warmer is right in that region where we define El Nino or La Nina events. So bottom line, what that means is you've got the global oceans are getting way warmer, and you've got this little patch of the Pacific that sets the tone for global climate that's actually trending cooler. So that increased contrast is leading to more frequent La Nina events. We had a 3-year La Nina that lasted between 2020 and 2023. We had a 1-year El Nino event in 2023 that faded out. And then last winter, we had yet another La Nina event. And we may well dip back into weak La Nina conditions again in the fall of 2025, winter of 2026. So 5 La Ninas in 6 years. Very unusual historically. We've never actually done that before. There's only other 2 instances where there's been 3 consecutive years of La Nina, looking back at the historical record as well. So La Nina is linked to a global weather pattern that tends to lead to high pressure systems over the southeastern United States in the fall and going into winter, and high pressure that's stable air, that's warmer than average temperatures, and it's usually promotes drier than average conditions. So unfortunately, La Nina events also promote higher risk of hurricane landfalls in the continental United States generally, but it seems seemingly specifically here along the northern Gulf Coast as well. So increased drought prevalence is likely linked to that increased frequency of La Nina events that we're seeing here over the past few decades.
Wow. Sounds like a lot of what you're saying sounds like a lot of unprecedented things happening lately. Does that make it kind of harder to predict, to model what's coming up?
It is, because, when I went through academia and I graduated with a doctorate degree in meteorology from FSU in 2015. And what I studied in, academia was hurricane history. That was, my focus was identifying why are some hurricane seasons more active from the perspective of United States landfalls than other hurricane seasons. So you can have a very busy hurricane season that has few impacts. No one remembers the 2010 hurricane season, despite there being 19 named storms, 12 hurricanes, and 6 major hurricanes, because none of them hit land. We care about landfalls. It's where people and things are that really matter. So I went in and I tried to look at the historical record and identify, what is it that drives that risk, those risks economically, the risk to people, and how predictable is that? So it's very frustrating for me as as a hurricane historian and a climatologist to be seeing these conditions that are not reflected in the historical record. And I'm a forecaster too. I'm down getting my hands dirty, every day making forecasts for agricultural interests. I'm writing hurricane forecasts, for the Democrat and for my newsletter, so I'm down in the weeds, day to day here, and there's lots of things that are happening that we don't have great historical precedents for. There's more things that are possible in weather than are dreamt of in climatology. Unfortunately, we're just changing that kind of what I would call, putting the statistician's hat on, the background distribution that we're drawing from is changing. Potentially due to some natural influences, but there's an strong anthropogenic fingerprint on it as well.
Gotcha. And so I was looking at the Weather Tiger website. So you use proprietary algorithms. So talk about the technology now that's used and how it's helping you, this kind of new technology, but also how much more public-facing a lot of this technology has become. And you see a lot more people posting, spaghetti maps and all this. Just talk about how technology is changing sort of the face of meteorology and meteorology as perceived in the public.
Sure. Well, what I'm doing at Weather Tiger primarily is I'm taking data sets that are being made available publicly through the National Weather Service, through NOAA, and by law, all those data sets, any data that the NWS or NOAA are generating must be made available to the public at no charge. But there's a profusion of data. There's far more data available than we're able to make sense out of. Currently we have. So what I'm doing is I'm going into those data sets and I'm using my scientific training from my academic life to responsibly extract insights from that data set and turn them into forecasts that are useful and usable for my clients. And my clients can include people who are reading the newspaper or reading my Substack newsletter, or the clients that I'm working with in agricultural meteorology. So what I'm doing is I'm going back and I'm identifying the patterns and other instances where highly impactful weather has occurred and making probabilistic forecasts about how busy is hurricane season going to be from a landfall perspective based on that information. What fingerprints can we go back and we look at as things that have reliably and consistently provided us skill in being able to say this is going to be a bad hurricane season or this is going to be a not so bad hurricane season. And that democratization of data, it's a great thing. It's what I've made my career on, basically. The flip side of that is that with so much data available, if you do not have a scientific background, if you do not have the scientific training, or, let's take a step further back. If you are a bad actor who's looking to construct a narrative for hyping up, extreme events or making irresponsible predictions to scare people, you certainly have the ability to do that with the wide variety of weather models and modeling data that's available. So, great example, just, out there right now, we have what I think just became Hurricane Aaron.
Right.
There was chatter from social meteorologists that, Aaron was going to be a threat to Florida. And that just, there never was the case. That was always something that was an extreme outlier possibility. But if you were just perusing social media, it wouldn't feel like that to you. You'd have your emotions played upon to feel fear, to be afraid that this is going to be a highly impactful event, when in fact, there really was never, more than a 10% chance of any significant weather impacts on the U.S. East Coast. So, as I like to say, bad information can circle the globe before good information puts its pants on.
Yeah.
And I feel like a lot of what I'm doing is just, kind of fighting these rear guard actions to, say, no, this is kind of the responsible take on this.
Right. And working in media, I think we always talk about media literacy. There are so many sources of any kind of information. And so for weather, how do we judge what's a quality weather source compared to, something that's more preying on our negative emotions?
Well, the great thing about weather is it's a pretty short-fused system when you're making predictions. It's very prediction-based, and you get to have a W or an L in a week or two.
Yeah.
So I would urge listeners to keep track of the wins and losses of the weather data sources that they're relying on. No forecaster is perfect. I certainly have, made errors and made mistakes. It's just part of the job. There's an inherent uncertainty into making forecasts. And a good forecaster, the job of a good forecaster is to communicate that uncertainty, communicate the different possible outcomes, and, balance that by, you also want to say something useful that someone can use to make a decision. So you don't want to say everything's a possibility, but essentially you do need to balance those two things, the usefulness with the, possibility that you could be wrong, and you don't want to be an overconfident forecaster. But at the same time, if your forecast source is saying and alerting you to things over and over again that don't happen, that are scary, that are frightening, that are extreme, that's an L. Keep track of that. Don't follow data sources that are leading you astray over and over again. And it's an easier thing to do in meteorology than it is in some other fields too.
True. I guess before I move on, what's the forecast for this hurricane season?
Well, I don't think it'll be as bad as last hurricane season. I don't see the signs that we're heading for what we would call a hyperactive hurricane season, where we're 165% or more of an average hurricane season. But I do think it will be a generally busy hurricane season, busier than our 50-year, 75-year averages. Last year at this time, my forecast models were indicating that the U.S. was likely to see a total of 4 or 5 hurricane landfalls in the continental United States over the course of the season, and we had 5, unfortunately. This year, that range is 1 to 3, and normal is 1 to 2. So we're putting a little more probability in the 2 to 3 range than the 1 to 2 range that we normally do, but I'd say there's a 75% chance that we'll see between 1 and 3 United States hurricane landfalls between now and the end of the year.
All right. Well, we'll check back on that.
Yeah, well, keep track of those wins and losses, folks. That applies to me too.
All right. Now, Jenny, so you also deal with a lot of pretty new technology to look at, I guess, our forest lands. So talk about what's the name of your presentation?
I think it's the next generation of satellite imagery for detecting plant communities in the southeastern U.S. I might be wrong on that. I presented. I have a paper that's closer in line to that, but I do remote sensing, so that just means observing the Earth from above. So we use satellites or drones, but really I work with any data as long as it's associated with a location. And so for this project, I came in and we're using satellite imagery, and we're actually using the next generation of satellite imagery. So you said multispectral, but we're actually using something called hyperspectral. And I guess sort of to orient, so these are satellites taking images of the ground, and in a typical camera image, you have pixels, and almost when you were a kid, maybe you pressed your face up against the TV screen like your parents told you not to,
right.
And you could see the individual pixels, and they were a line of red, green, and blue, and each of those are at different intensities, and then you back up and you're like, wow, this creates so many different colors. And each of those intensities for those 3 colors is a number. And so for something like a multispectral satellite, you have, somewhere like 11 to 13 different colors with their own number, their own intensity. I am working with a satellite that has 240 different colors. And so, in the multispectral, they're sort of bins. So you have red, green, blue, and then you get into the infrared. And so in the same way that we can say that a color is red, this satellite, can pick out like maroon or fuchsia or crimson. In a theoretical sense, they're each wavelengths of light. And so this became like a really valuable technology because it the way that it interacts with plants, and it's used a lot for plant health. So plants when you see them, they're, to our eyes, they're green because they are absorbing all of the different colors and reflecting the green. It does the same thing with the infrared. And so we use that as a measure of plant health, but we can also, there's different pigments that could be picking up from a satellite. And this is the idea that we're using to detect different plant communities. And so we're interested in the native pine savannas of the region, flatwoods, pine savanna, sandhills, upland pines. But we're also interested in separating those from the pine plantations of the region that don't, manage with fire as much, and more mixed pine forests that have maybe previously been these pine savannas that have had fire excluded, and so the hardwoods kind of take over.
Before we move on from that, so
Sure.
just to explain to our audience, so you're talking about a lot of different flavors of a sort of a related ecosystem. So talk about, just break that down for us, the longleaf pine ecosystems and their different flavors.
So the upland pines are more in this Red Hills region. They have a lot more clay soil, and they're all each of these ecosystems is dominated with an overstory of longleaf pine and a lot of wiregrass understory. This differs when you go to for the sandhills, which was our main site was the Ordway-Swisher Biological Station near Gainesville, and they have more of a turkey oak component, whereas we have like the southern red oak, and then in the Orlando area at the Disney Wilderness Preserve, which is one of our other sites for this project, has the flatwoods. And on the coast here, we also have flatwoods, and that has more of the saw palmetto component in the understory. But yeah.
Yeah, and you were talking about, excluding fire. So when you talk about pine plantations, you're talking about, these were cut down and then replanted with a lot of times slash pine, right?
Mm-hmm.
And
Loblolly.
And loblolly pine, and that these ecosystems would have naturally had regular fire, correct?
Exactly. Yeah, long history of fire in the southeast, and with still a lot of fire on the landscape. I believe that 5 million acres are being managed with fire in the southeast annually, and it's very important for our ecosystems, like I said, so that they don't, so we can maintain the understory. So, for example, in our upland pine savanna ecosystem, we can have up to 52 species in a 3 foot by 3 foot area. And so, and that's probably the most in North America that you'll find. And so to keep that, you need fire on the landscape. And so that's one thing we're looking for is, because 80% of the Southeast is privately owned land, we don't really know where all of those examples of ecosystems are. And so it's important for us to know so we can prioritize our conservation efforts.
Gotcha. And so now you're looking at it. So instead of like maybe having to go survey this all, by driving and visiting all these places. So, and now you're doing it with this new technology. So what do the extra colors tell you beyond just the pigmentation? What benefits are there to having more of a color spectrum, I guess?
Yeah. So in the way that we do the work, we do use machine learning. So it tends to determine for itself what is the most important. So we don't really know, but it could be related to leaf waxiness, or even in the understory, the soil moisture, or things like the anthocyanins, the red pigments, or the carotenoids, the orange pigments in the plants. So we really just let the model sort of determine, what's the most important. And a lot of it tends to be even just the amount of chlorophyll that you see in the plants, but.
Gotcha. So you're saying machine learning. So this is still learning. So you said I saw in your description for this, you got 76% accuracy when you ground truthed it, right? So talk about that. How teaching this and having it teach itself. I guess how what these ecosystems really are.
So thankfully, we're working in an area that has a long history of research in the plant communities, and so we know where these ecosystems are for the areas that we work in. And we're able to, tell an algorithm, hey, these are known areas. Can you help us with these photographs find other examples? And so we use random forest modeling, which is made up of decision trees, which are essentially flow charts. So hundreds of flow charts, that help with pattern recognition, essentially, yeah.
Right. What are some of the uses for this going forward? I mean, what are some of the things that really will enhance the research at Tall Timbers from this kind of work?
Absolutely. And so the state of the project now is not publicly available, but we've gone out and field truthed a lot of it, and we did find, even in areas that we thought had previously been surveyed, for the wiregrass understory, we found new examples of it, and we're able to add that to our internal database. But we use models similar to this that are publicly available, such as the land fire from the U.S. Forest Service, that does break down ecosystems in a similar way using the multispectral satellites, actually. And yeah, those help us determine where to prioritize conservation.
Gotcha. So we were talking about, before we started recording, about your background is you've done more on the talk about your background. So you didn't just start with computers, right? You were
I mean, I guess going back to my graduate work, I actually studied Arctic carbon cycling and worked in a lab a lot. But I realized that wasn't quite for me. And so I did, leverage my computer skills to do more of the remote sensing. But even I had a period where I was doing post-wildfire vegetation surveys out in the Sierra Nevada and California. And I think that really helped me, understand the role of fire in ecosystems. And and I get to help in prescribed burns every once in a while at Tall Timber, so that's lovely.
Yeah. Do you think it helps to be on the ground and also looking at it from that
Absolutely.
really cool...
I mean, you need the on the ground to inform the models. There's not really a way around it. You have to tell it what to look for, and so you have to know yourself, really.
Gotcha. So you're doing this really high-tech way of mapping ecosystems and our Earth. Mm-hmm. So Jim, now your presentation is talking about a lot of map making in the 1500s.
Right. It within the last decade anyway, archives all over the world, well, probably in the European Union, the United States, Australia, places like that, have started to make and digitize their historic maps, which is wonderful because you can just download them and then compare and contrast. And that really hasn't been around that long. And it turns out, so if you're a Spaniard, you've got a new world you just found, and you need to map it. But how do you map a sphere and put it on a flat piece of paper? So the Spanish government first employed cartographers, and then, no, we need cosmographers, the people that look at the observable universe, bring it back down to Earth, and let's see what we can do. And one of the most famous, I think, was Alonso de Santa Cruz. He and a fellow you may have heard of before, Sebastian Cabot, was the Sebastian Cabot was the pilot major for Spain. And they went on an expedition from 1526 to 1530, and they wanted to get around into the Pacific, but the headwinds were too strong. So they stayed on the coast of South America, then into the Caribbean, from 1526 to 1530. The Narvaez expedition took off in 1527. So by the time that Narvaez expedition had disappeared and nobody knew where they went, they just disappeared in Florida someplace, they had to know about that. So Alonso de Santa Cruz comes back to Spain and gets his degree in cosmology and becomes the cosmologist for the King of Spain, King Charles V, and begins mapping the New World. And there were other people doing that at the time, but one of the problems was nobody could figure out in the ocean with an astrolabe, which was the instrument you used, they couldn't calculate longitude, so they only had latitude to go by and estimated distance traveled. So when they were in the middle of the ocean and trying to figure out where they were, the Spanish call that a point of fancy because they didn't know really where they were. They knew the latitude, they didn't know the longitude. They had a compass heading, they'd stick to the compass heading. Anyway, long story short, Cruz was definitely a scientist of his time. He actually developed a map of Spain in 1543 or somewhere in there. That was a longitude-latitude map. Now, wait a minute, you couldn't do longitude back then. Well, you could if you were on land and you paid attention to things like solar eclipses or lunar eclipses. And he did a map of Spain that looks like a modern map. It's longitude and latitude with little grid ticks on the side of the map that researchers since that time say it was more accurate than Mercator's maps, which were done in the 1590s. He did these in the 1540s.
Right.
But anyway, he did not have longitude to go on at all. So he trained the ship's pilots. The King of Spain made it a mandate, and they went and started mapping the New World, wherever they went, an island, along the Gulf Coast, wherever it may have been. So his map of 1542 and then 1545 places Florida you can find the Big Bend on that map. Let me put it that way. Earlier maps you couldn't, because the Gulf of Mexico looked like a semicircle. But he's definitely got the Big Bend. And he puts an object there that says the Bay of Merlot, or that's not how you pronounce that. But anyway, It was Diego Merlot was the pilot for Narvaez, and they end up finding a bay at 29.5 degrees latitude. And everybody that's looked at maps, they never had the ability to get all these maps together and look at them at the same time and cut them apart because they're digital.
Yeah.
And all that. Anyway, the Bay of Merlot was in the Big Bend area. It was not down in Tampa. The way it gets mapped out in 1542 and 1544, and then Sebastian Cabot comes out with a map in 1544, and here is where the Narvaez expedition landed. And why that has been ignored all these years, I have no idea.
So there's confusion about where he landed, because so some maps say he landed closer to the Osceola River, but I've always heard he landed kind of closer to Tampa. And then,
well, that's where that's the conventional thought.
Yeah.
Now, to mix it up a little bit more, which I'm going to get myself in trouble academically, but that's fine. I love this stuff. Hernando de Soto had a scribe who described how they got to Florida. They got to Florida by finding the dry Tortugas and taking a due compass course north. Back then, they had no way of correcting for magnetic variation, which was about 9 degrees to the west at the time. So you had to correct back to the east 9 degrees to get on true north, if that makes sense. They didn't have any way to correct that. They didn't know how to correct it or why to correct it, because it wasn't common knowledge to the average pilot of a ship. If you do that, you're going to end up around the Osceola River or somewhere thereabouts. You're not going to be anywhere near Tampa. You're not even going to be within sight of land of Tampa.
Right.
So, anyway.
So you've been looking at a lot of different maps that are digitized. So how consistent are their depictions of the Gulf around Florida and the Big Bend area? Yeah,
in the first place, nobody knew that the Gulf of Mexico existed quite until 1519, when the first Spaniard went around the coast and got back to Veracruz and said, there's no path. They were looking for a way that was simpler than the Straits of Magellan to get to the Spice Islands in the Pacific, and there wasn't any in the Gulf, but they didn't know that. So 1519 is when Magellan did his trip. 1519 is where they first find out, well, there is a Gulf of Mexico type of thing.
Yeah.
And as maps went, Ponce de Leon, 1516, I think, is when he tried to go into Calusa territory and establish some kind of settlement there, and it didn't work. He got shot in the rear end by a Calusa arrow, and he died of septic 10 days later or something. And really, there was a big slave trade back then. And the slave trade were Spanish privateers that were going along the coast of Florida or anywhere else to find native peoples to put into the slave business of the big plantation owners in different places. And they sort of preconditioned the attitudes that native indigenous people had towards the Spanish. And Narvaez's expedition didn't work out too well, and neither did De Soto's. But De Soto meant way up into the Americas. I assume they had an astrolabe to do positions of the various Indian towns, because it was Alonso de Santa Cruz who did another map that shows where those settlements were out to the Mississippi River before the survivors of that expedition got the heck out of there. So the Spanish never really occupied Florida successfully until Pedro Menendez de Alvarez came in 1565, but they weren't looking for riches. They were looking to drive the French out of Jacksonville area and sort of secure the seaway for the Spanish galleons that were going back to Spain with the riches from Central and South America. But I digress. There's a lot of information, I think, in the Big Bend that points to that. And cosmographers were used under the reign of King Charles V and Philip II. But Philip III, I'm tired of this stuff, so he just got rid of the cosmographers and back then it was top secret stuff, their maps.
Right.
But he gave it to everybody, and the Dutch picked it up. So you got to go to Dutch maps after a certain point of time, like 1570s or something. And there's a whole, Dutch West Indies Company. And there are so many Dutch maps out there that are late 1500s, early 1600s, that show the same thing time after time after time. Even the French map, French Huguenots did a map, Debray, and it shows, I can't pronounce the word, but it translates in to the Bay of Merlot. So, there's a lot of evidence of that, which, anyway, it was fun to go through and that type of thing. I'd like to show everybody all of those maps, but I think you would get bored quickly.
Oh,
anyway.
So this bay is originally thought to be closer to Tampa, but it now turns out it's maybe more like Appalachia Bay.
Well, you read the account, and they landed, but they didn't have a bay. Mm-hmm. And there was supposed to be a bay. Well, this guy that was the pilot was supposed to know about it. Well, it was his uncle who had found some kind of bay and also had traded trinkets to the natives in that area for gold and other things, but mainly gold. And this guy came back to Cuba just bragging about, like, I'm rich. And it was one of the reasons, I think, that these expeditions started flooding into Florida. Where is it? Where is it? But it wasn't there.
Right.
It's probably off a Spanish shipwreck somewhere that's out there in the Gulf, who knows where. But anyway.
And so Narvaez is sort of a famously disastrous expedition, correct? There's a couple survivors that float over to...
It's one of the more interesting stories. There's an 1871, I think, publication. You can download it for free. It's the English translation of Cabeza de Vaca's account. So he starts out in 1527, and 1530-something, he ends up in Mexico City. That means he was in Florida, went down to the Bay of Horses, probably near the mouth of the St. Marks River, builds some kind of watercraft. There were actually 3, I think, watercraft, but his was the only watercraft that made it to the Texas coastline. From there, they took and went due west until they hit the Pacific Ocean, and they had to turn and go down to Mexico City, and they show up back down there. I think 3 of them survived.
Yeah.
But it'd make a hell of a movie.
I know, right?
So...
So a lot of the work you're known for is sort of prehistoric archaeology,
Yeah.
which seems a lot different. There's no text, there's no maps that
Right.
Talk about the difference in that. It's the kind of information you have to work with when you're dealing with that kind of a site compared to this seems like more robust amount of information, even if it's contradictory and maybe a little more confusing in a way.
As you guys know, there's a ton of data out there in any of your disciplines, and you got to figure out what you're going to use and that kind of thing. When you're dealing with prehistoric archaeology, it's more the hard sciences, looking for pollen or carbon dating, those kind of things. But when you get into historic archaeology, it's another ball game. And the Spanish were very good record keepers. Anyway, it's been an education for me. A professor over at University of West Florida, John Worth, has given me a lot of really good advice.
Yeah.
And I'm trying to get a paper published on that right now.
Gotcha. And so you're also going back to this coastline, and you're mapping with LiDAR now? Is that?
I'm just probably insane for doing this, but I'm trying to get a map pieced together that covers from, what would that be, Alligator Point to just south of the Dead Man's Bay, Steinhatchee, Florida.
Okay.
And it goes out 35 meters below sea level. There's brand new LiDAR. And then I'm trying to pull the land-based LiDAR and go all the way up and have a map for the conference. I don't know if it's going to work. I'm about ready to kill my computer or my kill me out anyway. But
talk about the LiDAR scanning. So how does that work for our listeners and viewers?
It's similar to what Jennifer's doing, but it's different. It's a laser. For land-based LiDAR, you use a red laser. For bathymetric, you use a green laser. And you need clear or fairly clear water to be able to do the bathymetry part of it. But when you get it, it's really high fidelity. And I think USGS, probably in cooperation with the Florida Geological Survey, have been collecting this data now. And the first scraunch of LiDAR for offshore is for Appalachia Bay. And I found a lot of interesting things out there. I don't dive anymore. I have to get some of my friends to do it.
So Appalachia Bay is theorized to have a lot of pretty good archaeological material in it. Can you see evidence of settlements and?
Yeah, there's a fellow named Mike Fott and Andy Hemmings and a number of other archaeologists, Jessica Cook Hale, Jesse Halligan, have done work out offshore.
Yeah.
And we started it, Mike Fott and I, 1986. He wanted to come over and find some underwater prehistoric sites offshore. And I couldn't believe that. We got a little clunker of a boat and went offshore and found 3 sites on the first day.
Yeah. Does LiDAR help find more sites? Or?
Well, we didn't have LiDAR back then.
Or now, but would it now? Does it have that usefulness?
It does because it finds outcrops.
Oh, okay, right.
Or it finds a sinkhole.
Yeah.
And some sinkholes are bowl-shaped. They're probably backfilled with sediment, but others look like they maybe have a cave or a spring.
Right. And those are places where I guess the artifacts would be protected from wave action. Is that?
Yeah. I went out and helped Mike Fott, and then Fott did the rest. And there's been a number of articles written about that. But the only in-place stuff that I have seen from offshore was probably older than Paleo-Indian, during a time when sea level had been close to where it is now, and then it went down. And when it did, trees grew up on shell beds, like oyster shell beds and things like that.
Right.
And then we came back and did some excavations and got down on the shell layer, and why is all this wood here? And one of the fellows I was with sort of stopped everything, and he dug the way archaeologists don't usually. and uncovered the wood, and they were tree roots.
Okay.
So
Yeah.
anyway, it's out there. It's just not intuitive always how you find it.
Right, right. And so we're talking about a lot of new technology. So talk about, I think, in all your fields, I mean, the technology, how often does it change? And is it hard to keep up with for
Well,
anyone?
it can be. I mean, there's technology I wish I knew about or knew how to crunch the data, but I'm going to rely on somebody else to do that, looking for the nanoparticles that indicate extraterrestrial airburst or impact or whatever it, yeah, and, so you have to rely on your colleagues.
Right, right.
Well, I'd certainly say in meteorology that things are changing quite quickly. I mean, one of the things that is just now coming to the forefront are machine learning or artificial intelligence means of doing the type of weather prediction that we're more used to full physics models doing. And we've kind of gotten familiar with those over the last 20, 30 years. Now we're starting to have some pretty strong evidence that these almost more statistical approaches, which use huge training sets, can approximate some of the skill levels for certain applications. But this is very new stuff.
Yeah.
I mean, a lot of meteorology is being able to recognize predictable biases in models, and then you can correct for those. The American model tends to have areas of high pressure that are too weak off the East Coast, so it tends to take hurricanes too far east. Over time, you can observe cases like that and then correct for it.
Yeah.
Well, we don't really know what the biases are in the artificial intelligence-based models. So that's something that really, this is the first hurricane season that a number of them are available. A few of them were available last season as well, in a more kind of widespread way. So it's something I'm looking at and evaluating as a forecaster. But again, also just to go back to that conversation we were having about, bad actors acting on information.
Garbage in, garbage out.
Exactly. And if you have far more models, you have all the physical models that you used to have before, and now you have these AI models. Well, it's just it's a choose your own adventure. There's more things to select from and show. Oh well, in 15 days the AI model is showing a major hurricane approaching Florida. Well, does that mean anything? No. I mean, we don't. Furthermore, we don't really know because we don't have the context of seeing how it's performed. We don't have those skill scores going back a few years. And I think that's really key in meteorology to be able to kind of understand not only what the forecast is, but as a meteorologist, why a forecast is what it is. And that's something that the AI approach really takes away from you. So I guess to sum it up, field is changing very quickly. I think it's very promising for certain applications, but we need to evaluate those very carefully. And of course, just with the media environment and that we're in, people are very afraid of artificial intelligence. I'm more afraid of natural stupidity.
Gotcha. How about for you? Is that,
Yeah, even for me, because I do use machine learning, and I am given a lot of opportunities to continue learning in my career, in my position, which is really lovely. But even still, there's lots of machine learning models that I know very little about, and then it gets into deep learning, and that's a whole new ball game. So, yeah.
I think the black box approach to science is not a good way to go because, so much of science is the ability to help people understand and explain something and in a responsible way to tell a story. And I fear that as we're automating, if we automate too much, we'll get away from that kind of meaning that we can, extract from data.
Yeah, and I can definitely see the pros and cons. I think, there are efforts to try to make the machine learning even more or less black box and, get into what it is actually doing. And so there are ways to get at what it's picking up.
I have GIS program that has AI built into it now, but I haven't used it yet. Where I guess you could tell them, well, this is what this kind of target looks like. Find more of them.
Yeah. I think that's,
with square miles of area to look at.
I think that's sort of what I was going to add is that, like, I think in some ways you do get better accuracy with machine learning. And so if you're robustly testing that accuracy, if you have examples from a large area and, you're not applying the model to things that's never seen before. So I think it is really context specific, and people definitely misuse those sorts of things. For sure.
And that's the big problem in meteorology, is that so much of the value in my world is driven from being able to make good, probabilistic forecasts of extreme events. And by definition, extreme events are rare.
Yeah.
So it's difficult to establish trends. It's difficult to have enough events that go into a training set that are relevant.
That makes sense.
And that's what's causing the damage. It's not, AI does a great job of telling you that today's going to be 92 with a 30% chance of thunderstorms. We just don't know how it's going to fare forecasting, a Hurricane Andrew or an Irma or even a Helene. It's something that we're going to have to evaluate over time, and we're going to have to do it,
tweak it as it goes.
Yeah.
Yeah, which is science.
So, but in theory, if it keeps learning, it should only become more accurate, even if you can't see inside of how it's working. Is that accurate to say that, or do we know?
It's hard to say, because the physics inside the core of a major hurricane are very complex.
Yeah.
And the greatest gains that we've seen in forecasting accuracy, we do a much better job now than we did 10 years ago, even than we did during, say, with Hurricane Michael in 2018. We are doing a much better job of forecasting cases where a hurricane jumps very quickly from a tropical storm to a Category 3, 4, or 5 hurricane. 72 hours before landfall, Michael was a tropical storm. It strengthened to a Category 5 hurricane in 3 days. National Hurricane Center initial forecasts were calling for a Category 1 or 2. Now fast forward to Helene in 2024, the initial forecast for Helene, right off the bat, Advisory 1, it's calling for a Category 3 hurricane. It's anchoring those expectations to something much more impactful and much more realistic, and giving us better time. That's not due to AI. That's not due to machine learning. It's due to the hard work of NOAA scientists who have been conducting field experiments and building better physically based models of what's going on in the core of a major hurricane. And it's given those tools to the forecasters at the National Hurricane Center to be able to just have a better guideline for when is rapid intensification most likely, and how can we communicate that risk to the general public. We're doing a much better job of it now, and it's such a shame that we're not funding those efforts fully because they produce such great gains for society. The idea that we can just replace all that with, artificial intelligence is just specious.
It should be a tool, not something that's heavily relied on and just go away and have a Coke or something.
Oh yeah, no, I mean it's a great efficiency tool.
Yeah.
But it's a great efficiency tool to allow human beings to do what we do best.
Right.
Which is actually do that critical thinking.
Yeah.
And also, balance that with what's going to benefit society the most too.
Right.
So
Yeah, and talk about the human part of this too. It's not just there's a lot of data, but taking it, I guess, shaping it into something useful, but also communicating that. And talk about your jobs as storytellers, as far as taking all of this and making it meaningful to people and then useful to, I guess, the public.
Yeah, I mean, useful and usable is my motto at Weather Tiger.
Yeah,
and that is scientific knowledge in a vacuum that isn't understood or applied is not providing benefit to society. So that's, everything that I do is very much trying to think hard about how to get people to take the right things away from my forecast. And the right things are, my number one goal is that people have the most lead time that they can possibly have for a high impact hurricane event or other weather event. And the flip side of that is, not overwarning people, not scaring people, not having excessive false alarms. So,
Yeah.
yeah, I mean, it's weather really provides that like fast feedback on being able to communicate, because you're either getting through to people with they're either taking the right message away from your forecast or they aren't. And unfortunately, I've had a lot of experience in the past 10 years of having to communicate highly impactful hurricane event risks here in North Florida.
Yeah.
Yeah, but it's very much needed too.
Now, unfortunately, it has been.
More and more.
There's never been another period in hurricane climatology going back 175 years where we've had 10 major hurricane landfalls in a 9-year period along the Gulf Coast. So we truly are living through an extraordinarily active period of those high impact events, both in North Florida, specifically, and for the Gulf as a general region.
Yeah.
So talk a little bit about the lineup. I saw that there's multiple different categories of
Right.
So let's go over that a little bit, I guess.
Well, the first series is going to be foodways past and present. And Andy Hemmings is going to be one of the speakers. He will talk about the plant that were available, edible plants that were available to Paleo Indians way back when. Tanya Perez is going to be talking about Mississippian and earlier cultures that were mound builders and midden builders and what they had for a diet. And then we're having a fella, John Latson, talking about the lifeways of the Osceola Rivermen, 1900 to 1940, which is really sort of fascinating.
Yeah.
It's a little-known story. The Great Depression hits. People go to the Osceola and the Wassissa River because there were wild range cattle all over the place. There were wild pigs. In the winter, they had the mullet runs. It was a way to make a living with very little money. And those people that herded cattle would ship them off to markets, whatever markets there were during the Depression. So that will be an interesting talk.
So you're covering all the way from at least 14,500 years ago to the Great Depression. Wow.
Yeah, right. Great Depression to World War II, basically. And then we have influence and climate events in the Big Bend area, and we have Ryan speaking on the weather tiger, I should say.
Yeah.
Speaking on hurricanes and how they develop and the conditions for wildfires and tornadoes that we unfortunately have had here that really caused some damage. Ralph Clark is an interesting speaker. He's worked for DEP for maybe 30 years now, and he is the one that goes into the field that does the assessment of damage of buildings and structures, not everywhere, just on the coast. And his findings are very enlightening about the last 3 hurricanes that hit here. And the Cat 1 did the least damage, and the Cat 4 did the most damage, which should be expected. Morgan Varner, who is with the Tall Timbers Research, will talk about plants that are adapted to fire-prone areas, which should be interesting.
Yeah.
Because we have a lot here, although not every place. I mean, if you're in an oak magnolia-type hammock situation, you're probably not going to have great forest fires rip through.
Right.
That have spruce pines instead of yellow pines. The spruce pine has no sap. It doesn't burn very well, those kind of things.
Any upland, I guess, in the American Southeast, I guess, more or less, is a fire-adapted.
Yeah, well, there's fire-adapted
yeah.
and wealth of resources, aspirations for the future. Tony Murray will give a talk. And then the keynote speaker, Bruce McFadden, who just retired as a major paleontologist at University of Florida, will talk about Florida prehistory for everyone. And I think he's done a lot of things, but he likes the original Pleistocene horses of Florida. And then we're going to go to new technology, understanding, and knowledge base. And Jennifer Rogers is going to talk on the new multispectral imaging and what it's capable of doing. And I'm really anxious to hear that because I think it's cutting edge science right now. Brendan Fentry, the geologist. He was working for a mineral exploration company in Canada now, has taken some fossil bones we have gotten out of the Osceola River as well as the Wassissa River, and they're quite different.
Yeah.
In the Osceola River, they're coated with this iron deposit goethite, and in the Wassissa River, there's none of that, and he has taken ground up bone powder to find out what chemistry has happened to those bones since they got deposited way back when.
Would it have to do with because those rivers are really different in quality as far as the Osceola being really tannic and dark,
Right.
and the Wassissa being a spring-fed clear river?
I think you could look at the Osceola as a river that's been underground primarily and slowly coming to the surface, and it collapses in, and then you get a channel, and one end is a spring and the other end is a siphon.
Yeah.
Whereas the Wassissa has always been a surface channel. Broad, flat surface channel. And it's one of the, I hate to use this word because most people won't know what it is, but anastomosing,
Right.
which is a very slow-moving river where people like Karen Berensmeyer in Olduvai Gorge would find ancient riverbeds like that and find the best fossils of early hominids and try to decipher how all the scatter of bones fit together. And in anastomosing rivers, you often get articulated skeletons rather than just scattered all over the place, which is interesting.
Yeah.
Ben Tanner is University of Stetson. I actually went to school with him way back in the days, a geologist that's been doing organic sediment research in Florida spring runs and has found some interesting things. Conservation in the wilderness in Big Bend. Hillary Barnhart is with USDA, and she'll be talking about the conservation efforts here in this area and the Big Bend in general. I put him in twice. I'm missing somebody there, sorry. Willett Boyer is going to be talking about work at Floyd's Mound and some other early contact sites in Florida, and then I'm going to give a talk on really early navigators prior to 1565 and what they knew about the Big Bend in Florida. So,
once again, I guess the First Floridians Conference is October 3rd and 4th, the Monticello Opera House. One thing too, real quick, let's just, there's also going to be an artifact roadshow.
Right. We're inviting farmers and local folks that might have a collection they found in the farmer's field, wherever it is. If they want the artifacts identified, bring in no more than, I think it's 20. We don't want to get deluged with 1,000 potsherds.
Right.
But, the ones that may be unusual, we might be able to go ahead and say this is a certain type, and that type has an age range of this to that, that kind of thing. And we did that 4 or 6 years ago and had one person bring in a spectacular piece.
Right.
Every once in a while you get surprised. Mostly it's the same thing over and over again. Probably the most common artifact to find in Florida is a stemmed archaic point, sort of a Christmas tree-shaped thing.
Right.
But there are other types out there. So anyway.
Sounds interesting. As a long-time PBS guy, sounds like a really familiar concept, that the road show.
Yeah,
Great.
right.
So,
well, we sort of borrowed that.
Well, I think we borrowed it from BBC, so it's fine. So thank you all so much, Jenny Rogers, Ryan Truchelet, and James Dunbar for joining us. And this has been Coast to Canopy.
Appreciate it.
Thank you.
Thanks again.
In this episode of Coast to Canopy, we talked about 500-year-old maps, hyperspectral imaging, and a few varieties of the longleaf pine ecosystem. If you're a visual person, you can see all of that at wfsu.org/ecologyblog. The video version of this podcast is also on the WFSU Ecology YouTube channel. We also heard a lot about the Page Ladson site and North Florida's remarkable prehistoric archaeology. This was the subject of our recent documentary, Finding the First Floridians. That's also on the WFSU Ecology blog and YouTube channel. This podcast, the blog, and documentaries such as Finding the First Floridians and Secrets of the Seep, we couldn't do any of that without viewers and listeners like you. If you want to support ecology content on WFSU Public Media, you can do so by joining the Seed Circle for a $10 a month donation. I thank Seed Circle members on every episode of Coast to Canopy, and in our second month, we have a few new names. Thank you to David Blair, Carol Goodyear, Chris McFarland, Carrie Maddox, Clara Mullins, Alina Pryor, Kim Sash, and Donna Tharp. Even if you don't join the Seed Circle, any amount helps. And for a $7 a month donation, we'll send you a WFSU Ecology blog calendar with photos of my North Florida adventures. You can make your donation at wfsu.org/ecologyblog. This has been Coast to Canopy, an ecology podcast from WFSU Public Media. Today we had Evan Rossi running audio, Aaron Welch, Ian McGordy, Paul Dam, and Jason Acuna handled video. And they spruced up the lighting in our studio. Ian McGordy edited the video version. And I'm your host, Rob Diaz de Villegas.